Hello,
Good afternoon, sir.
very good afternoon. How are you?
Sir, I'm good. How are you, sir?
Fine, fine. Managing somehow, passing the whole day. Uh,
Yes, sir.
a lot more activities are there, so I'm not facing any problem because the research scholars are there. So many administrative work. Then we are planning for the courses, whole course design. Okay, so there's no
Yes, sir.
time issue for me. I'm busy with the whole day actually.
Sir, even we have some assignments of different subjects.
Yes. So maybe next week I will plan slightly differently. I'll just take the other course also. Let's see how things run because after 40, because they have a lot of rush also in Zoom also. That's why the problem, they are not even extending the time.
Yes, sir.
Yeah. So and actually we need to pay little amount for extending the class more than 1 hour. So let me see if some problems are there, I will pay, and maybe I'll talk to director regarding this. Once you pay some amount now, it's not that much. So I'll talk to director also. Director was in the opinion, if free classes are available, so you go for it.
Yes, yes,
But
exactly.
infrastructure should be provided by PDP authority, no? That is there. Okay.
Hmm.
So it's okay. Let's see, because this sort of situation nobody predicted.
Yes, sir.
Yeah.
Unwanted.
Yeah, unwanted, and and this long time actually, it's a world war actually. If you just if you can
Yes,
say
yes.
if somebody has done it purposefully, then it's a world war. I mean, they have involved every
Hmm.
country,
Yes.
everybody is in the real problem. Okay.
Hmm.
Uh, and
Even it is, sir, scary. Like it is very
yeah,
scary to get out of house.
you have gone out from house, because I went 2 3 times today also, a little bit to the gate of my society. I mean, really scary. Even if
Yes, sir.
you don't know what is going
Yes.
to happen.
Nobody is there.
Yeah, yeah.
Hmm.
So that is typical. I don't know how things would be managing. Even
Yes.
the lockdown is over now. Still, people will not.
People will be scared. Yes.
Yeah, I will not go
Yes.
continuously. So this is how
Hmm.
really this April whole hopefully will be in very problem. My apprehension, even because whatever the is sent actually, the registrar. It is from your case, it is from
Hmm.
28th or 23rd of April, no? Have you seen the
7th,
schedule?
27th. Yes.
23rd.
Yes, sir. Yes.
Okay, so that
Hmm.
is, but still it's a doubt, because still cases are reported, numbers of cases. Even you see the
Yes,
yesterday,
and
day before yesterday, the numbers of cases, and so that's why even what happened, we are really illiterate in terms of that. So we are hiding ourselves. Okay, but you cannot escape.
yes, we are unable to.
Yeah. So we are not coming.
Exactly.
Okay, test my case, and you just, if I may be in quarantine, because the problem with everybody here.
Yes, sir.
I don't know. So no, what about the others? So Sunday is, everybody is considering it's a Sunday. nobody nobody joined till date. What now, isn't it? So
I think so,
think
sir.
somebody joined. Yeah, Ali is there in the. Okay. How
Yeah,
about Ali?
Ali is
You?
there.
Hi, hello, sir.
Fine, fine. Hello, good afternoon. So,
Good afternoon.
okay. So are you going through the, yeah, particularly your the courses for this instrumentation part? Any YouTube video you have seen? Yeah.
Sir, actually, we have a deadline tomorrow for submitting the assignment of parasite geology. So, sir, after that, we'll try doing that.
Okay,
Yes, sir,
okay.
because
Okay. I'll give you also. I am not purposefully giving you assignment actually. Okay, so let us plan something differently, because assignments is not that you. I'll just try to give you brief. So whatever 2 books I have given you, na, for this
Hmm.
3 books I have given actually. One is your management. Assessment, development regarding the your appraisal stage. Another is reservoir characterization, and third one is the reservoir management. Okay, So if possible, you just go through this initial 2 books, okay, not the management part. You'll come to know one by one. So that part. So this is a very important aspect for reservoir characterization, because everything we need to do it as a geoscientist or maybe reservoir engineer. Okay. So let us wait for another 2-3 minutes. I don't know, because I have sent WhatsApp message, but nobody responded on this. Regarding Suman or Kishan, any news with you?
No, sir.
No,
Yes,
na?
sir.
Okay, so means I send at least to expect something. Yeah, okay, what is their condition? They are joining today or maybe like that. Because once I have to repeat the class with everybody, then it's a real problem, isn't it? Because
Yes, sir.
yeah, okay, so we may, how long we'll get the time? Somebody, acha, oh yes, Abdul has joined up, na? Hello, Abdul, how are you? Hello. Okay, so hello, are you?
Hello, sir.
Uh, uh, okay, so 4 people, including me, we joined. So let us wait. Hello, are you audible?
Yes, sir. Yes.
No, other Ali, is it? Am I audible to you?
Yeah, yes, sir.
So regarding yeah, our it's not audible. Hopefully, he is. Hello, his connection is still not stable. Okay.
Hmm.
Okay, so we'll start a bit. We have discussed this part already. So you see how we collect samples. Can anybody just Ali? Could you just brief me what we discussed regarding crude oil, or how, let's say, during the initial stage of drilling to the end of our, let's say, field development or maybe abandonment, what are the different activity related to fluid? Any, just give me a broad idea. I wanted to know how much you are involved in this, because we have discussed this in our previous semester also, and initially also I have a few classes I have discussed, trying to discuss the holistic approach. You need, people have to, because these are the idea you need to know, or you need to remember in a broad spectrum. Okay, so if I just start with this, so during drilling we got certain information, isn't it? What are the
Yes,
information we gather?
Yes, sir.
Okay, what are the information we gather? Let's say during drilling,
Fluorescent.
yeah, mud logging.
Madlog,
Very first is
Madlog.
mud logging. Yeah, mud logging. What information we
Hmm.
gather regarding fluid? We got certain information. Okay, gas or hydrocarbon fluid are there or
Type
not? Yeah,
of.
yeah, yes, yes. So by
Hmm.
actually from the fluorescence, we got certain information, isn't it? So
Hmm.
that is the first information
Hmm.
we gathered. Even during the mud logging, the geologists note down regarding the fluid from the chips, rock cuttings or chips. So that is the first
Hmm.
physical information regarding the rocks and fluids. Okay. So
Hmm.
now when we are drilling, we complete the drilling sometimes, or we complete drilling, we collect samples. By how we collect samples during that time? Any idea? Modular dynamic tester, if you remember.
Hmm. Yes, sir.
Yes, yes. So modular dynamic tester, I'll have a few slides. I'll just go through one by one. So modular dynamic. So just giving you a framework in just in 2-3 minutes. So then
Hmm.
what we do once we collect the modular dynamic tester, because we can. There is an advantage of modular dynamic tester, isn't it? We can module wise we can lower down our module and collect samples sequentially from different layers. Okay, so this is just nothing but the aspiration. I'll show you picture. I have already shown you earlier, but still I'll just try to repeat the same thing with Then we complete our well, cement the last casing, then we perforate,
Hmm.
and then
Corporate.
we allow the well to, we stimulate or activate the well and then allow the well to flow, isn't it? Then
Hmm.
what we do, we collect bottom hole samples, if you remember.
Hmm.
Isn't it? Bottom hole samples with the proper sampler, we just try to collect the bottom hole samples. Bottom hole samples we collect, then for that volume is very large volume we could collect, so that we are sending this to PVT cell for different
Hmm.
PVT study. Okay. And this is not only the very first time. We start with the exploratory well, and subsequently we go for different well also. Okay, so that is because you have got certain idea. Yeah, many way we are trying to get the information. Okay, then you see we could collect a bottom hole samples also, and we could collect samples from the surface also.
Surface, yes.
Okay, because what is no, because the homogeneous true representative sample is very important for us. That's why we are managing to collect samples from surface also by combining samples from the separator, because we have the volume
Hmm.
estimation from the separator, the how much gas is producing per day, how much liquid is, how much water is producing. So by combining the volume or understanding the volume which we are getting, we will collect the samples. Okay, so that is how. And also flow line samples. If let's say THP, you heard about this term THP, tubing head pressure. Okay,
Okay.
tubing head pressure means the pressure of the tubing. If it is more than the bubble point pressure, means higher than the bubble point pressure, then obviously your fluid has not evolved any gas till now. So that may represent your homogeneous representative samples of the reservoir. Okay, so that is how we are trying to collect samples. Okay, so and then it is in the initial stage, and then what we do, we that now with time, what it's the initial stage. Now you have a lot more time, you have started taking production, and we have seen in our phase envelope or understanding about the fluid, the composition of the fluid is gradually changing when we are taking the production, isn't it? Then what we do, we just try to get uh, other information. How, let's say the reservoir engineers, I told you the reservoir engineers are generally acquiring data with time. Okay, so year wise, when new wells are drilled, collect information. So much more information, core plug samples as well as fluid samples we are collecting each and every, not in every cases, sometimes we plan for it. It's not that we collect core plug samples from every well, we collect fluid from every well. Okay, so with time, so that is how. And who will who generally plan for it? Subsurface fluid and maybe the fluid samples, core plug samples, geologists along with the
Reservoir.
reservoir engineers.
Reservoir engineer.
Okay, geologist will collect, you know, you are studying the well site geologist, so now you can get the idea. The geologist will give the requisition for collecting a whole core samples, isn't it?
Hmm.
Not the other people. So they will collect, so that is for future planning. And simultaneously the reservoir engineers, after you complete a well, it was the responsibility of the reservoir engineer to get that well tested. That means they will collect the samples and they will do the well test, transient well test analysis, what I told you. Okay, so we lower down the instruments and we perform the experiment or maybe the testing, maybe for 5 days, maybe for 10 days, maybe for 72 hours, like this. Okay, I will maybe another 2-3 days I will try to get this idea. Okay, well, the two
Hmm.
three classes I will conduct. I don't know how much I could take, because we have time, but still I will give you some idea what is well testing, because you don't have any idea about well testing. Okay, so then what happened, they are doing the well testing. So that means in the subsequent development stage also we are gathering more information with time. Okay, so this is how we are going for collecting lot more information. So I'm just glancing through slide, and whenever required I'll just stop and maybe. So this is what we are collecting, how we collect bottom hole samples. You see, one is during open hole. Okay, this is formation tester, we have discussed this. Okay, but still some pictures are there, I'll show you. And so are you getting as a geoscientist, or maybe if you, because now you should not restrict your knowledge base only to the geological understanding. You should understand as an engineer, So you need to know what are the different activity going on, because the core company may have different domains of the expertise, but when if you are in service provider company, if you join as an engineer there, you should know the things in detail sometimes. Okay, so that is how your understanding, overall understanding, is very important sometimes. So we collect open hole, we collect cased hole also. Okay, so now what is open hole sampling? I discussed this part in your last semester also. Still, I'm just trying to sum it up so this is actually your modular dynamic tester. These are module based. They have a lot of complicated electrical circuits. If you see, these are actually the Schlumberger modular dynamic tester. Okay, we have the permeability measurement instrument, we have the pressure gradient measurement instrument, we have the PVT sampling, we have bottom hole sampling. So you see in the sampling, the right side figure, you see so many sample modules are there, isn't it? So red color inside. So that means simultaneously we could collect a lot of samples together when we are running down. Okay, so this is the advantage of modular dynamic tester, because we could even now the things are, we could understand the type of crude present in the well also. That is also there. I'll just try to show you. Okay, so this is your simple how you collect the sample. Okay, so what, just like you are putting, if you inject something in fluid, that is called injection. This is called aspiration. Aspiration means we take fluid samples from the formation. So if you see this is the domain where the formations are actually punctured, and your fluid will be collected. Okay, you have a strain gauge, and you have the this CQG is the quartz gauge actually to measure the pressures, and you can test differently. I'll just show you how we run this. So this is what. Okay, so multi probe, that means you may have a lot more probe. If you just go this figure, you can understand we have a formation, we have different probes, horizontal probe, vertical probes, and they are placed in different places. So when we collect some fluids from it, so what, you got certain pressure response in other probe also. So that gives us certain informations how the basically when we are drawing down how much actually. Hello Suman, is it audible?
Yes sir.
How many of you
Yes sir.
Okay, so this is what we do. Okay, so this is very sophisticated instruments, and the limitations of this instrument is you cannot test longer, and you cannot go beyond a certain domain. Okay, so that's why you see when we are testing for a very nearby area of a wellbore, what is the problem you may face? Any idea? Because during the drilling time we have damaged our wellbore surrounding, isn't it?
Yes.
So that means whatever fluid you are collecting, that may be not the proper fluid of the reservoir. So you are maybe collecting from a mixed fluid. So that's why we have
Yes,
different modules also. This is called pump out model. In pump out model, actually what you can get the resistivity value of the fluid which are entering into your instruments, and you can discard the samples. You cannot divert into a sample chamber. So that you could do. So how, you see, in order to recover PVT quality samples, because what the samples we are collecting, not for just for sake of sampling, it's for PVT. That means you need to know the proper PVT phase envelope, phase diagram, behavior, composition, every parameters. Okay, so that's why through the resistivity measurement, we'll try to know which fluid. How do you get this resistivity informations? We have some resistivity sensors there. And how do you distinguish? Can anybody tell me? How do you distinguish the original fluid of the reservoir is entering, or we have some invaded or maybe the mixed fluid? Because we know mud resistivity, isn't it? When we are drilling, we know the mud resistivity. So once you are getting the resistivity more or less similar of your drilling mud, that means the fluid which is entering into your sampler, that is not the proper reservoir fluid. Okay, so I'll just show you another diagrams that may give you the. It's not there. Okay, it is no, it is not there. Okay, some resistivity values are there. One graph is there. It is not here. Okay, so that means the resistivity value actually are there. So that can, so what, as an engineer, your role is to understand, okay, the fluid is entering into my it is online, you can see it from the surface. The signals will be coming to you. What is the resistivity of the sample which is entering into your sampler? Not sampler, actually, yes, your modular dynamic tester. So once you see this resistivity is similar to your drilling mud, then you discard the samples. You should not divert the sample to your sample chamber, isn't it? So when you think, okay, this is not the fluid which is entering, then you divert your sample to your sample chamber. Then you are trying to collect a sample, because what are the zonation there from the well bore? Can anybody tell me in terms of register? Because you are now learning the logs also. You have one domain which is called mud cake.
Yes.
Yes. Then after mud cake,
Yes.
you have the flush zone, RXO. Then you have the mixed zone. Then you are
invaded zone.
Yeah, invaded zone, exactly.
Invaded zone.
Yes, fine.
And uninvaded.
Uninvaded. So that means we try to
Uninvaded.
collect the samples from the uninvaded zone. So that is how
Yes.
this is the one advantage. And another, just you see, these are Halliburton different. You can see every parameter. Zero stock PVT bottom hole sampling, then formation fluid properties monitoring, dual probe anisotropic testing. So different types of modules are there. Depending on your requirement, you can lower down your specific instruments for getting the information right. Okay. So that means this is, you people may have to decide for this, because you see, when you people will be working as a well site geologist, that time you may have in the field, and particularly the reservoir people may come. And if you go to the field now, even today also, if you ask somebody in the drilling site, what is happening when this sort of instruments are lowering down, many people say, oh, bottom hole party is doing something. Most of the people don't know this activity, what is happening, what information they are gathering. Okay. So this is what, okay, so now here you can see all the test, pre-test, before we you just the 4 diagrams are there. Then in situ phase separation, pressure measurement, you can get the pressure variations, because I told you we have a lot more sensors are there, isn't it? Okay, in the same instrument, if you see in the right side, you have here in this part, you have inserted your instrument into the formation, and now you allow the formation to flow into, and accordingly you get different pressure response, and that gives you the idea how the, you see here the last one is fluid sampling. So you are sending your fluid to the chamber. Okay, so that means that these are actually, you need to take a call from the surface, because this will be displayed online into your particularly your video screen, or maybe your screen on the track, which is already built in computers, everything would be there, so that you need to monitor and take a decision. Now I should trap my samples in the full chamber. Okay. Got it? So this is what we do.
Yes,
And this okay, so now few things are there. I just I didn't put it here. Okay, so now we could analyze the fluids also online by using spectroscopy. That is light oil, heavy oil, everything we could do it. If you are interested, I have a book, I can send you sampling, and this is the most complicated part. Okay, so this generally I taught to the reservoir, but not you people but if you are interested, I can send you all the materials to you. Okay. So
Okay,
then
sir.
okay, so this is above surface. So now what happened after that? Once you collect your modular dynamic tester, what is next? Because modular dynamic tester is open hole, if you remember. Okay, we case the well, cement it, then we perforate it, and allow or stimulate or activate it, and allow the well to flow. Okay, so now this is the setup. Have you ever seen any Christmas tree? All
Yes,
of
sir.
Suman seen Krishna?
No, sir.
No, sir. Okay, so this is actually, you have two zones. One is the production pipe is going to the top, and another you see side one side pipe is going. That is actually annulus opening. Okay, annulus or maybe sometimes. So this is what is there. Different valves are there. So you just, because you I don't know your production part. maybe SSPC may touch upon this part after drilling and completion, isn't it? Okay, so hopefully, so you just have an idea for everything, because you must know this, because you never know when people will ask you question. Even interview board, you cannot say that I haven't studied this. Okay, so this Christmas tree, once above that, then what is done? So this is what we have discussed early. Because once you allow the well to flow, now you, because this modular dynamic tester will collect only few samples, that is not very much suitable for going for the PVT study, because samples is very small in amount. Okay, so then we go for bottom hole sample collection. So before that, what we do, we lower down our instruments, manometer. Okay, so this manometer or maybe electronic memory gauge, which collect information of the pressure, rho gh, when you lower down, because let's say you, pressure. Okay, so just this diagram will give you idea about how the pressure is distributed in a well. Okay, this is the well. Okay, this is the zone, and it is correlated. You can see from the top. Who generally does it? Who generally does it? Okay, so this is generally done by the reservoir people. Okay, so now this is subsurface collection of fluid samples. This is what is there, a sampler. I will try to send you another picture because yesterday I was just searching many things. I got few informations. Okay. So
hi Abdul, why are you not visible?
yeah, now it's visible now. Yeah. So some problem whenever some okay. Visible now. Hello. 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 Hello.
Say anything.
I can't see you.
Now is it now visible?
Yes, sir.
I don't know what is happening. Sometimes the data overuse of data or something is showing, and that is going out. Okay, so now the sample part. Then what we do actually in the sequence. Okay, this stop sharing. Now how we test it? Any idea how we collect the samples? Okay, so this is actually the sampler. If you see, this is a mechanical sampler what I used when I was in ONGC. Okay, so but I got few information electric sampler. Yesterday I just found out few information, so I'll just send you all that. Okay, so how we collect the samples? Just anybody? Anybody? So what is the step of collecting a sample, subsurface sample? So what we do actually, initially, let's say we have, this is the well, okay, and this is the perforation is already there. Is it visible?
Yes, sir.
Okay.
Yes.
Now on this top, this is a Christmas tree. So we used our winch van. Here is the truck. And from the track we have the drum where is there, where is we send through, this is called lubricator. Hopefully the pictures are there. I'll show you. Okay. Lubricator. Through it we lower down our instrument, electronic memory gauge, up to a certain depth. Okay, how we lower down? In a very specific manner. How? Let's say I just put, this is the time, and I lowered down. So I just set the instrument first, then I just lowered down slowly. So initially my pressure is like this. So this is actually the pressure value. Now initially when I was working with this part, before lowering, my pressure is 0. Okay. Now suddenly I lowered down up to 100 meters. and I keep for 1 minute, and the particularly the clock will be running. So the clock will be running in this direction 1 minute. Then I again lower down 200 meter. I stop for 1 minute. Again I lower down. So like this, I lower down up to the desired depth like this. So what is the value? Pressure? This is what? Rho, G and H. So that gives me, so I know the H, I know the total pressure value measurement. So G is my fix, so I can get the rho. What is rho?
Density.
Fluid type.
Density.
Density. That means if it is lighter, then I got the fluid. So on that basis, I try to get this information like this in the well. So this is very less rho, intermediate rho, and high rho. So what is this? Rho GH. This is very less. This is gas. This is oil, and this is water.
Water.
Got it? So this is how we try to get the information. Where is my water? What is my oil? And where is my gas? If it is there. If the THP, this tubing head pressure, is more than your bubble point pressure like this.
Then it is gas.
No, more than bubble point pressure means what I am trying to say. Let's say if this pressure THP, this is called tubing head pressure, top pressure is here, so definitely you will be in the single phase, so you won't get gas here, isn't it? Because gas has not evolved up to that.
Evolved. Yes.
Not evolved, because pressure is, you see the THP is higher than the bubble point pressure, so that means you will get only a single column of oil and water if water is there. Now you tell me where from you will collect samples. Two situations. One is whole oil, another is gas. In case of oil, if you collect above the transition zone, that means you will be getting the higher pressure crude oil samples, isn't it? Okay. You have 10 minutes left, okay, in our hand. Okay. So then you say lower down your sample sampler, collect the samples. Fine.
Sir, can you repeat the last point, because I couldn't hear
So
anything.
there is a problem in the connection. If you can
Okay.
repeat
Okay.
the last one.
So you see, if the pressure of the tubing head pressure is more than the bubble point pressure, so no gas will be involved in this, isn't it?
Yes.
So we'll get only a single like this, oil and water. If the THP is here, tubing head pressure, this is here, then means we may have some evolved gas also. So in this case, we'll get a slope like this. Okay. So now where from you will collect your sample for PVT?
For PVT, sir, oil.
Oil, yes. Where from? Where you will send your sampler up to this level? Not here, because it would be water.
Yes, sir.
We have to collect the samples from here only. Got the idea?
Yes, sir.
Okay, so this is how to collect bottom hole samples. So that means what we have to do, we need to collect samples. Okay, so now unstable, yes. So now bottom hole samples, oil head samples, and surface samples. Okay, so now it's clear how we collect the recombination samples, the surface samples, because yes, what we have to collect from separator. Okay. Got it now clear? We from the beginning, we are collecting different fluid samples for our different activity, for particularly for PVT study. And this PVT study, hope you remember the PVT different flash liberation, differential liberation, then you have constant volume depletion, separator test, all we are doing for our different understanding of the crude behavior. Okay. So now this operation part is clear, how we collect samples. Yes or no? We don't have much time, so maybe I'll just okay. So how we recombine? You see, recombination means we go for the volume estimation or volume measurement. in the reservoir or maybe in the surface separator. We collect the samples in the volumetric proportion and put it and recombine it. How to recombine? Like this, it's a recombination setup. We mix it and we just char it. Okay, so that you see this is the recombination cell, and we have a pressure gauge. We can also increase the temperature so that the reservoir sample should be of reservoir pressure temperature value. Okay, and once you are trying to mix it, so what we got a samples, even surface we got a samples of above PVT, above your bubble point pressure and temperature. Okay, so that is how we are preparing. We are getting the samples from surface, we are mixing it proper production volume, and then we are mixing it and make it high pressure temperature, reservoir pressure temperature, to make it an homogeneous reservoir samples. Okay, now constant composition expansion, then we have, okay, so this already you have studied, I hope, last semester. Okay, I'll just, this is, you see, constant composition. So composition is not changing. You see, here is the liquid.
Yes,
We
sir.
decrease pressure and we observe it in each and every point, and then we just try to get this graph. Okay, this is for constant composition expansion.
I think we can't hear anything, sir.
You cannot. Okay, let me just repeat it. Okay,
Okay, sir.
so repeat this part. Okay, slide share. Okay, so this is what, so now what we do, we collect the samples, and depending on the reservoir pressure temperature condition, what we do, we just, if you just see the particularly the graphs, isn't it, we just lower down here in the last gas condensate diagram, you see one arrow is there,
Yes.
constant arrow. So that actually we take our PVT cell into that pressure temperature condition, and then we reduce the pressure. In the previous case also maybe same. Okay, so that is how we try to understand our phase envelope. So what is your idea about phase envelope? So phase envelope, what we discussed so far in our normal classes, phase envelope, we don't get it like this for our own samples. Okay, so what this is actually for our understanding, we just draw this diagram. But for normal cases, let's say we got our samples here, and the pressure, this is reservoir pressure temperature condition. So we take our PVT cell into that pressure temperature condition and got a line like this only. Only this line we got, and from this, we are trying to develop our own understanding about our crude oil. We don't get the other part. Are you getting my points? It is not the whole phase envelope we got. We can get the critical point and we just do like this. So that is how we build our understanding about our own reservoir fluid in PVT. And from that, we calculate whatever is there. Okay, calculate the parameters for everything. The slides are not okay. So you see, for differential liberation, what we do, we just take out the gas, and then each and every step we do it. Okay, so this is how we just try to get our different value of BO, BG, RS, RV, every parameters we get it. Okay, so this is how each and every samples we collect and get the parameters. Okay, constant. Why we do the constant volume depletion? Anybody? It is written here in the constant volume depletion. What it is? Pore. How it would behave in the pore scale. Okay, so how it would behave in a pore scale, that can be easily understood by this. Okay, so that means how a pore, because if you remember our fluid equations, when we discussed about the equations, and particularly two-phase and three-phase relative permeability graph, okay, the values are generally changing.
Hmm.
Okay, and that part to understand that, because ultimately what we need to predict the flow behavior of the crude oil with time, because we are now in a process of how the reservoir will behave, how the crude will behave, what is their production rate with time, that we need to understand.
Hmm.
Okay, so that is how
Yes.
our PVT parameters is important. We could do the separator test, that is generally by the production people, but we need to know it for our own activity. Yeah, how this fluid will behave with time. Okay, this is a schematic. Okay, so got this idea or not?
Yes, sir.
Now if you have any questions, you can just ask me. Suman, are you there?
Yes, sir.
Okay, so how many of you joined today?
4.
4.
4. Acha, 4. Na, okay, okay. So any questions out of this? Why? Because you see, for developing or for development geology, first
Sir,
part is, oh, tell me.
sir,
Ah,
can you send me this PPT? PPT?
it's already
Yes,
sent
sir,
to
we
you.
want.
All 16 PPT I sent you.
Okay, sir.
You just see it in MTech, MTP 19. I sent all 16 I will add more basically. Just you go through the books and this PPT. If you have face any problem, I am always with you here to support you in every,
Okay, sir.
even if you send me any questions in the WhatsApp, I will immediately answer.
Okay, sir. Okay, sir.
Main part is you just study this